To verify Boyles Law, we use the Boyles Law apparatus. Okay, so let's look at how it's set up. So at constant temperature for a fixed mass of gas, pressure is inversely proportional to volume. That's Boyles Law. So we can write it mathematically, pressure proportional to 1 over V, and therefore it's a constant times 1 over V. We want the constant must be a constant, so it should be a straight line. So on the y-axis we put P, on the x-axis 1 over V, and our slope would be our constant. We know it's constant because it's a straight line through the origin. There's no C value for y is equal to mx plus C. So let's look at the apparatus. Okay, so this is our apparatus. So we have a piston that allows us to change the volume of the gas. The most important thing is the gas. It's all about the gas, so label the gas. And in the cylinder we have a scale that measures the volume. In this case it's millilitres. It doesn't matter that it's not an SI unit because we're not doing any calculations. We have a pressure gauge here that measures the pressure, in this case in either pascals, because it's 1 by 10 to the power 5 pascals, or just in atmospheres, which is 1. Simple with the 1. Again, we don't need SI units because we're not doing calculations. Okay? And we have a tap. Okay, so at the moment, the mass of gas would change if I move the valve, because gas will go out here. So before we start, to make sure it's a fixed mass of gas, we close the tap. Okay, we close the tap. Now, in this case, we'll start at this point. Okay, so at this point, we're at 260 or thereabouts volume, and we have a pressure of 1. Okay, what we have to do then is we have to change the volume. So we change the volume by moving the piston in here. As the piston moves in here, the volume will get less, the pressure will get larger, the pressure will go up, and we keep measuring volume, pressure, and then we draw a graph, and we verify the law. There you go.